Great. Thanks for having me. So, yeah. So let's pronounce my name perfectly. I'm Xiangning Chu. So, in Chinese, Xiangning Chu. And Chu Xiangning maybe because we have last name first. So, I have been working with on Steve for a while, like since 2018, like during summer. That's when I first hear about Steve. And initially, I was working on something else, like from a space scientist point of view, we're looking for waves in the magnetosphere. And then we hear about the talk by Liz, and we thought, okay, so it looks like they are in the same region, so maybe they are connected. So that's why we first studied. So I'm from LASP Boulder. So that's where Allison was before. And these are my quarters. I think we don't usually do this, but so Lucas is an undergrad that works with me on Steve. And Colin and Neil are citizen scientists who provided great photographs for us. So that enables this study. So let's move on. I mean, I assume you know Steve somewhat like in some level, but here are some pictures of Steve from citizen scientists. And Steve is absolutely different from regular aurora. So the regular aurora, like seen in this photo, is usually green and it dances rapidly. But Steve, on the other hand, they happen at much lower latitudes where we don't expect aurora. And also Steve is kind of like a line. So they are east-west aligned and they are pretty stable. Oh, the size, so good. Excuse me. So it's pretty thin in the south-north direction. And most interestingly, it has two different kinds of lights. So you have this pinkish light and also those green lights. So they are like picked fence. So that's where the name comes from. And there is a saying that aurora is the TV display of the magnetosphere. So, those shapes give you an idea of, what causes Steve in space. It has to be long, thin, and stable. So the first scientific report is by Liz, who's here in the group. Though we all know like Steve is not totally new, it's been observed before. But this is the first when we scientists realize, Steve is totally new from regular aurora. And in this report, there's, in the background, there's photographs from citizen scientists. And also there are scientific all-sky cameras, which capture Steve, that's this line. And a low Earth orbit satellite crosses Steve about 500 kilometers above the Earth. That's pretty low in terms of satellites. So what they observed very strong electric fields and a very hot plasma. So that's likely what's causing Steve. That's the first scientific report. And in another paper, we reported what causes Steve in space. So by space, I mean magnetosphere. And by the way, this is way higher, is 20,000 miles in space. So when satellites cross Steve, so that's, if we look here in this all-sky camera, that's where the footprint of satellite crosses. So this is Steve. And then here in the pink color, I marked where one satellite crossed Steve, and we observed also very strong electric field, very hot plasma, and also strong waves. And so we think these are causing Steve in space. I said about the TV display thing of the magnetosphere, right? So in this saying, so this is Earth. This is the magnetic field lines of the Earth. And those reddish thing is very hot plasma in space that's traveling along the magnetic field lines and causing aurora. So it's kind of like a TV thing. So you imagine, this is a TV tube, and then you have, heaters that heats the plasma in space. So that's what we call the magnetosphere. And then the plasma was traveling along those magnetic field lines, and then it hits the atmosphere. It's like the TV screen, and then it lights up in the atmosphere. So that's what we usually think.
Xiangning,
Mm-hmm.
could you go back for just one? And maybe we will see if there are any questions at this point, but could you point out on this nice cartoon kind of where the satellite in space is roughly that the previous data was from, and then also just say more about, connecting that on the, how that is connected via the magnetic field to the ground observatory location as well.
I see. Okay, sure. So in Lee's study, I said 500 kilometers above the Earth. So that's here. You can barely see it because the Earth is 6,000 kilometers. So that's what we call atmosphere or ionosphere. In my study, we have satellites roughly here. So that's 4 Earth radius from the Earth. So roughly here. And then we observed very strong or heated plasma here. And then we have to shift this reddish thing to here. Then imagine, the plasma, or most importantly, the electrons, negative charges. So are traveling along the magnetic field lines and then heating the atmosphere. Is that clear?
Yeah, that answers my question. Thank you. Does anyone else have any other questions about any of the kind of slides up to this point? I know you definitely have more, but there's
yeah, I mean, I showed
a lot that you showed already. So yeah.
Yeah, I showed this to my wife, and she said, it's not quite explaining itself.
No, we don't have any good cartoons
yeah,
of
I
Steve,
know.
I don't think, because this is like an Aurora cartoon. And then Steve is also, lower latitude, so kind of below where the Aurora is here.
Yeah,
but
I agree with you.
And it's also 3-dimensional sort of, yeah. Oh, there we go.
So if we have to use a pen to draw this, right? So the reddish thing was way down tail, like around 7 or 10 RE or even further. So that's 60,000 kilometers away from the Earth. So that's where the regular green aurora is caused, and it has to be very energetic plasma, very, very hot. In terms of Steve, is actually much closer to the Earth, only 4 RE, Earth radii from the Earth. And then if we have to follow the magnetic field line, in terms, sorry, it's really bad drawing here, but you can see, they map to different regions. One maps to very low latitude, and then the other one maps to higher latitudes. So that's why, when we see regular aurora, it's way in the north, and then Steve is way in to the south.
Anybody have more questions?
I mean, we can answer questions at any time. I mean, I'm trying to use plain language as much as I can, but I don't know much of the difference between plain language and scientific terms. But
yeah, it's always something to gain experience with as well. So yeah, I think you're doing great with the language. But the plots are complicated. So maybe we go back to the plots, but I think this is a really interesting chart. Actually, why don't you keep going with the chart, and then we can circle back if there are more questions for that. But
sure. I'm going to use this plot in the next slides too. So okay, so we talked about what causes aurora in space, but there's another thing. or scientifically explanation recently that they think the Steve is not generated in space. They think that the Steve is generated locally in the atmosphere or in the ionosphere where this the gas is has charges. So they propose that the plasma responsible for the green impact fence should be generated locally. And what's the difference? The difference is the same cartoon, but this time it's kind of like a short circuit or kind of like electric stove. And you still have the battery in space, but what is getting hot is the gas in the atmosphere, and when it gets hot, it emits emissions, like kind of like electronic stove top. It lights up in red color. So the main difference will be that there's no electrons or plasma from space. There's no need for that. You can just heat locally in the atmosphere, then it generates Steve. So the question to me is where is Steve generated? Is it generated in a kind of like a short circuit locally in the atmosphere, or is it generated by hot plasma traveling along the magnetic field lines, kind of like a TV plasma tube?
I think this is like a really, really interesting question about Steve as a phenomena that's less familiar. It's definitely different in how it's caused than the usual aurora. And so this is an interesting way to ask the question. I guess that it's also one of the reasons why, as people investigate Steve with data from different sources, like your background as more of a magnetosphere person looking at data from magnetosphere satellites, that might be, as you said, kind of where you started. But then also we have so many different silos in our field of the ionosphere people and the magnetosphere people don't always look at things in the same way. So I think that's really interesting because I think it has, Steve is such a challenge because of that. And personally, I think it might even be a little bit of both. The green picket fence especially is kind of pointing to the role of the ionosphere. But certainly Steve is related to the process of aurora that is largely driven by things happening in the magnetosphere as well. So yeah, I wonder if anybody else has any thoughts on that or.
So when I draw this cartoon, I mean, I have a battery here where I marked magnetosphere. That's my little trick here. I think, whichever scenario is correct, it doesn't matter because you have to drive, both scenarios are actually driven by space. So you have to have a battery in space. So that's what we usually call a driver or a generator in space. So
I guess my question for you is, could it be a little bit of both as well? So you've presented it as an A or a B, but there's also an option C.
I agree with you. I mean, in the last slide, I'll say, it's still an open question because we don't have direct observations that will, tell them apart. But I agree with you that it could be both. It never is a one mechanism working alone, like because this is a process that's coupling space and atmosphere. So
great.
Yeah, but I put the scenario here because what we call hypothesis, like in space physics, because you have to catch people's eyes and make people understand, what was the main thing that we were targeting. So much about that, but when we talk about prediction, if we want to look into what mechanism might be, right, then we have predictions, right? What do we expect? Actually, in this work, we're expecting to study the height of Steve, and also whether the green picket fence, it follows magnetic field lines, and also whether the green picket fence, like, the green thing, are on the same magnetic field lines with those pink Steve. These are important because remember I was talking about, how those hot plasma has to travel or fly along magnetic field lines. They cannot, transverse. They cannot travel perpendicular along the magnetic field lines in general. So knowing if they are on the same magnetic field line will help us answer this question. So in our past study, we actually have a few scientific cameras, like, those kind of like all sky cameras, and using triangulation, we found that Steve is about 250 kilometers high. But this is not helpful to answer any of the questions we had because the resolution of the all sky camera is very low. Nothing compared to, DSLR. So here it comes to our latest study. Citizen scientists plays an essential role in the discovery and research of Steve. So in this event, we were very lucky that we have two citizen scientists capturing the same Steve event from two different angles. So it provides a very unique opportunity to study, what Steve looks like. So here, this is captured by Colin. He was right underneath Steve. So that's why, this kind of like pink Steve overlaps with the green picket fence here. So roughly along the magnetic field lines. And another photo by Neil, he captured from the side. So you can see, how Steve was at different heights. So the pink one is higher than the green one. So with that photographs, we can determine the sky map or looking angles. What we did was like we identified the direction of every single stars in the background. So we know, in these photographs where we are looking at. And then we can do the same thing for Colin's picture. What we can do then is plot the magnetic field lines on top of those photographs. And you can see the black lines here. They are magnetic field lines. And we are plotting for different heights because the magnetic field lines are falling from the sky. So the reddish line, well, they are 400 kilometers and then 300. And then another red one is 200 and 100 here. And then at the bottom is 80 kilometers. What we can learn immediately is like the pink emission is about 200 kilometers. And then green picket fence is lower at about 100 kilometers. But I think the most important thing from this is that the green picket fence, you can see their shape. They follow the magnetic field lines very well. So that's the key takeaway from these photographs. And what we can learn next is, so with all this, we can stretch this photo, right? So we can stretch the photo according to different longitudes as I plotted here and different heights. So we get this one. This image is the same photo, but as what we call as a function of longitudes, but it basically, it's just a stretch of the photo. And then also it shows the height. What we can do, what we can see from this photo is like the pink Steve is about 200 to 300 kilometers, but its most bright spot is around 200 kilometers. And then here is the green picket fence. Remember, it was here, but when you stretch it, stretch the photo, it got squeezed. But this is a green picket fence, and they are at a height of 110 kilometers, so roughly here. That's when we plotted only as the height distribution or height profile. So what we can learn from this photo is this is 110 kilometers, and this is where we expect green aurora, because the plasma, when it flies and reach the atmosphere, it has a specific energy that it has to emit green bright at this altitude. So pretty close or consistent with the regular green aurora. I'll skip this one. Okay, one more thing before we conclude something. So let's go back and think, back up a bit, and we were wondering if the pink emission and the green picket fence, are they on the magnetic field, the same magnetic field lines? And this is where we look into that. So this is still the colon picture, a zoom in version, and these are the pink emissions. And if we plot the magnetic field lines from the center of the pink stave, and then that's all these lines falling from different locations. I hope you can see it, but that's the one in the middle. And I can't zoom in here, but I can tell you that if the magnetic field lines are falling from the center of the pink stave, then they can reach the green picket fence. But if we plot the magnetic field lines falling, slightly away from pink stave, what do we know is the end points of those magnetic field lines, they don't reach the green picket fence at all. And if we plot the magnetic field lines offset from the other side, their end point here, well, they don't agree, or they don't reach the green picket fence at all either. What this tells you is the pink emission has, well, the pink emission is on the same magnetic field lines with the green picket fence, because otherwise the magnetic field lines doesn't reach the green picket fence. So with that, so what can we learn from the shapes of the stave? First, the green picket fence, its emission, the height of that is the same with regular green aurora. And then the green picket fence themselves, they follow the magnetic field lines very well. And then also in the last slide, we show that, the pink stave and the green picket fence, they have to be on the same magnetic field lines. So in my mind, if we have to go back to this cartoon here, I think it tells you, right? So first, if the green emission is 110 kilometers, it has to be, well, it's very likely to be a very energetic electron that's reaching the atmosphere, so that's causing green aurora. And also they are all along the magnetic field lines, tell you that they are probably something that's traveling along the magnetic field lines. And it indicates, their source is from space. There might be argument that maybe the green emission are generated locally, and then it somehow goes up and down along the magnetic field lines. But I asked many experts in the field of ionospheric dynamics, or those experts, they cannot think of one mechanism that will cause a perturbation in the atmosphere that will be that will cover such a height in for like hundreds of kilometers. So I think that being said, those are still, like, all this evidence are still in favor of the thinking that the Steve is generated in space. But the last thing I wanted to say is this is still an open question, because we don't have direct observations inside Steve that we can tell exactly what's going on. So that's my last slide.
Great. Thank you so much. Thank you. I really like how you've kind of presented this work on Steve as, a series of, to me, my opinion is we're kind of chipping away at understanding more and more about it. I'm not sure if I totally agree with all of your conclusions, but, the point is that it's still in a state of open questions that we're still looking more as well. So I really appreciate that and want to get questions from other folks. We have probably 3 or 4 minutes for a few more questions. We had a little conversation in the chat about how great the analysis is that you're doing with these citizen science photographs, and also some of your examples with satellite data have just very close conjunctions, very strong conjunctions of the satellite and the time of the observation. So anybody want to offer some comments? Michael? Yes.
I have a few questions, I think more than we have time for to answer. I can send you the questions later after this meeting. I think one thing I realized in the Steve image you show here right now is that there are some slight bands in the greenish picket fence structure, and I'd like to ask if you have any explanations for that. I think this is a case where these deviations from the magnetic field line seems to be minor. I know cases where these deviations are much stronger. This is first question, and the second question is you showed a projection of this Steve, and if you have a closer look on the projection, I think it was the slide 2. Okay, yes, the image on the left side, and if you have a look on the red, green, blue projection, you can see that there are structures in Steve that changes in height in east-west direction. So they are in the western part lower than in the eastern part. In the western part they are higher than in the eastern part in your image, and it's a lower one. And I'd like to ask if you know of other cases where this structures can be seen in more detail, because I have some very detailed images showing that these structures evolve from the upper height region of picket fences, move with picket fences, and then rise in height towards west. So it's look like some kind of smoke that rise from the picket fences. Of course, this is a wrong picture, but I think it should be very important to have a closer look on such structures, because this structures shows a connection between the picket fences in the lower height regime and the upper parts in the purplish part of Steve. And if you're interested, I can send you high quality data for that to have a look at.
Yeah. So sorry about this. Now I see why this might be misleading here. I was only abstracting, the science question in a kind of like a higher level, or higher level structure. But I didn't mention what Michael just mentioned is, if you look there, right? So that's what Michael called stake or streak structures, that they at the end of the green impact fence, that they don't follow the magnetic field lines. They actually, in his paper, he showed, they are also not only not along field lines, but they are traveling. So these structures are the what we call evidence, or they suggest that maybe those emissions are not following along field lines, so they might not be from space. These are generated locally. So I totally agree with that. Now I see what these comments are, and I totally agree with that. I still think, like we said, it's an open question, and different structures in either the steel or green impact fence, they might be contributing from both mechanism, or they're not dominated by one mechanism. And then the second question is, so there are structures here. So first is they seemed like to be different heights. So Jun Liang from Calgary University, we have another paper on what we call two-layer stave. So that's about this region where you see the pink emission, which although it's 200 kilometers, there's another layer at about 150 kilometers. So they don't have to be on the same magnetic field lines. Oh, sorry. I mean, they don't have to be on the height of 200 kilometers. Somehow they can, somehow, I'm sorry, I can't get my face from this sunshine. So somehow the pink emission is generated about 150 kilometers. So that's totally different, and we still don't know exactly what's causing them.
Yeah.
And
Sorry.
we actually have, we have some explanation for that, but that's only just scenario that I don't have time to work at all. But if we look here,
I think we might have to move on, Xiangning.
Okay. Yeah.
But it's super interesting, and I think Michael also has been is very familiar with the citizen scientist photographs, and probably has some really amazing photographs showing exactly what you're talking about, which is kind of some of the steves that go from this main altitude down to lower altitudes, and that's also telling us some clues about the mechanisms as well.